Hello, this is Mr. Eric. I'm here to talk to you today about 12.3 surface areas of pyramids and cones. First off, we're going to talk about pyramids, then we're going to transition into talking about cones, but really there's a lot of similarity between the two, and when we get to volume, you'll see there's a lot of similarity in how we calculate the volume of pyramids and cones as well, so just kind of follow along here. When we're dealing with a regular pyramid, anytime it tells you it's a regular pyramid, right up front, you know we have a regular polygon for the base. It could be a triangle, it could be a square, those are pretty common, but it can go up to an octagonal pyramid. I've seen that one before. Obviously you can go further than that. It's not common to do so just because it can cause some real problems and the numbers start to get pretty messy. There's a slant height. Anytime you're dealing with this, and on page 854, again, there's kind of a better illustration. They can print stuff in 3D. But you've got your height, which goes from the peak of that pyramid down to the center of that base, be it a pentagon, a hexagon, whatever. It goes down to the center of that. That is your height of that pyramid. But you also have your slant height. And the slant height is the height of just that one triangular lateral face. All the lateral faces on these pyramids are all going to be triangles because they converge up to a point from the two lines, the two endpoints of the side of the base there. So when you want to find the lateral surface area, you're just dealing with those triangles. It's 1/2 times the perimeter times that slant height. You're going to have to use the Pythagorean theorem probably in a lot of cases to find the slant height. They may give you the size of the base on the bottom and the height, and you'll be able to calculate from there, imagining that triangle kind of in 3D going like this, what that slant height of that side would be. Or you may have to use trigonometry if they only give you one side of it, the cosine, the sine. Make sure you kind of go back over those, remember those. The total surface area is going to be 1/2 times the perimeter times the slant height plus this capital B, which means the area of that base. Really, you can think of it as I find the area of the base, I find the area of the triangle, and I multiply the triangle by however many there are. You could do it that way. It's just this formula is kind of what they give you. You can, there's more than one way to skin a cat, especially when it comes to shapes like this. So you can kind of figure out how you want to think of it, how you want to approach it in your mind, and just stick with that. Okay, there's a lot of different ways that you can do this. If you don't want to know all the different ways, again, formula, memorize this. But if you don't need memorization to key in on this, the key thing here is to say, okay, all of these faces, in this case it's a square base pyramid, so all 4 of these triangles, and then that base thing. Now, when you're dealing with cones, again, you can have a right cone, you can have an oblique cone if they give you an oblique cone. Your slant height and your height are going to be kind of affected. Probably they're going to stick mostly with the right cones. They're not going to give you too many oblique cones just because, again, the math is going to be pretty difficult. The lateral surface area is going to be the surface area of what I like to think of as just the cone part, like the ice cream cone. There's no top on it. You don't have to worry about that top. You're just going to find the surface area of that wrapped conical part. The total, of course, would be the base plus that conic part. This would be the net of a pyramid, or not a pyramid, sorry, a cone, which looks really odd, deconstructed, but it helps you kind of understand what's going on. We have a base, and that base has a radius. So the full circumference of that base going around is the sector of the circle on this cone, where the slant height is that radius. It kind of looks like Pac-Man up here. So we do 2 pi r for the circumference here on this conical part, and that's the circumference of our base. So it's going to be only a proportion of this. So if you think back to the last chapter where we did the areas of sectors, you need to find out, kind of where we are in relation to that when you're finding the surface area sometimes, or you just needed to kind of think about it. Again, the lateral surface area is going to be pi times the radius times that slant height. So we get, you know, that we get that thing there. We get the area here, and then we multiply by that slant height, and then on the total surface area, we've got that slant height times the radius times pi, and we add to that pi r squared, the area of that circle on the base. Today I would like you to do problems number 7 through 38. I'd also like you to add to your notes on page 858. There's kind of a cheat sheet of all those formulas. It'd be a really good thing to take down. I may have you, if you can remind me before we take the mid-chapter exam, go ahead and copy those formulas down onto just a note card, and that can be your formula chart, if you will, for working these problems out. We'll do 7 through 38 today, and that should be a good number to get you through it. Again, if you have problems during class, you don't understand what I was talking about here, you have trouble dealing with, you can't see it or whatever, make sure to come in, talk to me, give me a heads up on that stuff, raise your hand during class, and I'll do my best to explain it to you in a way that you can understand. We'll see you then.